All right, we're going to dive into chapter 8. As you can see here, right above my head, our learning target for chapter 8 is about classifying and applying properties of polygons. So we're going to spend a lot of time looking at all kinds of different things, whether it be parallelograms, trapezoids, or other types of polygons. But what we're going to start with today is just some basic properties of polygons. We're going to look particularly at the angles formed on both the interior and exterior of the polygon. Hopefully you've just successfully completed an activity where you've learned about the interior angles in a polygon, and that's where we're going to start today. So we can slide right on down here to theorem 8.1, our first theorem of chapter 8. The sum of the interior angles of a convex polygon is equal to, okay, and this is what you guys just learned, n minus 2 times 180. Important that we have our parentheses around the n minus 2 to make sure that we're following our order of operations. Convex polygon, so notice this works for any type of convex polygon. What does it mean for a polygon to be convex? Well, it means it's not concave. Okay? A concave polygon might look something like this. See how it has this indentation here? That would be concave. Convex doesn't have that, and you can look up at this. Okay. Here's concave. Okay. Take a look at this one. It doesn't have any of those inward vertices there. So this works for a convex polygon of any sort, the number of sides minus 2 times 180. And as you recall from the activity that you just completed, the reason it is that way is because if we split up the polygon into triangles, the number of triangles that there is always the number of sides minus 2. And of course we know the interior angles in each triangle is 180 degrees. So let's go through a couple examples here. Example 1, what is the sum of the interior angles of a quadrilateral? Well, quadrilateral, how many sides is that? We need to know our names for our different types of polygons. Quadrilateral would of course be 4. So we're going to take 4 minus 2 times 180. In other words, that's 2 times 180, or 360 degrees. Okay, you might recognize that from the activity that you just completed. And on some of these, as you start to just recall them, remember them, you don't necessarily have to go through this work. You know, quadrilateral, hopefully, you'll just always remember that's 360, and you don't have to substitute in the 4 anymore. But if I give you something with 36 sides, probably don't know that one, definitely need to plug it in. All right, how about this one? Find the sum of the interior angles of this convex hexagon. Okay, so I gave you a diagram of it. Okay, so you can count that, count the sides that way. Or you might just recall off the top of your head, a hexagon has 6 sides. So our n is 6. Okay, so we're going to take 6 minus 2 times 180 equals, I've got my calculator, that's 4 times 180. Okay, that's 720 degrees. Again, if you just have that remembered, you're good to go. Just make sure that you get that sum correct. Now, our next two examples are going to switch it up here a little bit on us. Okay. The sum of the interior angles of a convex n-gon is 1,260 degrees. How many sides does it have? So notice this is backwards of the last ones that we just did. Okay. Before, if I gave you the number of sides, you found the sum of the angle measures. Okay. Here, I'm giving you the sum of the angle measures. I want you to give me the sides. So, how would I do this? Well, what do we normally do? We take n minus 2 times 180. Okay, we plug in the n, we get the angle sum. Well, here, let's just take the n minus 2 times 180 and set it equal to 1260. Okay. Here's an equation. Can I solve this for n? Absolutely. Now, how would I go about solving this for n? Okay. Well, I see students do this two different ways. I see some students who like to distribute the 180. Okay, 180n minus 360 and solve it that way. I have other students who like to do it this way. Divide by 180. Okay. Gives me n minus 2 equals, I'm going to grab my calculator, 1260. Divided by 180, that's 7. N minus 2 equals 7. Add 2. N equals 9. Okay, 9 sides. Okay, what do we call a 9-sided polygon? That would be a nonagon. Make a note of that, nonagon. Okay. If you look at the way that I did our work here, I did it exactly backwards from the problems before. Here I subtracted 2, then multiplied by 180. This one I divided by 180 and then added 2. Gave me 9 sides. All right, let's look at example 4 and let's see how this one's different. Find the measure of each angle in a regular 15-gon. Okay. So 15 sides. Okay. I want to find the measure of each angle. I'm not asking for the sum. I don't want to know what they all add to. I want to know each individual angle. And let's see here. How could I figure this out? Well, I do know how to figure out what the sum is, so let's start by doing that. Okay, let's take 15 minus 2 times 180. Okay, that's 13 times 180. Okay, big number, 2,340 degrees. Okay, that's what they all add up to. Okay, now, a key word in this problem is that this is a regular 15-gon. What does that tell us if a polygon's regular? Okay. Well, doesn't it tell us that each pair of sides are congruent, all the sides are congruent, that all the angles are congruent? Well, if all the angles are congruent and it's a 15-gon, how many angles are there? There's 15 of them, right? So to find out what each angle is, we can take 2,340 degrees and divide it by the 15 angles to figure out what each angle is. So when I take that number and I divide it by 15, I figure out that each angle is 156 degrees. Does that make sense? Is that a reasonable answer? Can you picture that? A 15-gon, 15 sides, okay, going all the way around, okay, that each angle would be 156 degrees. Okay. Well, you know what I'm going to do? I am going to get on GeoGebra briefly. I'm going to investigate this a little bit to see if that seems like a reasonable answer. Alright, if I go to my polygon tool, I'm going to choose regular polygon. I'm going to click here and there for that to be my side length. Now it's asking me how many vertices do I want in my regular polygon. I want 15. 15 sides, 15 vertices. Whoa, there it is. Here is a 15-gon, a regular 15-gon. That's what it looks like. Notice it looks pretty close to a circle. You know, the more sides that we have in a regular polygon, the closer and closer it begins to look like a circle. Okay, let's check to see what each angle measure is. Okay, let's measure an angle, and I'm going to measure this one right here. We're going to go click, 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 and if you look at that, you can see our 156 degrees. Cool. Let's look at our next example. Okay. Find the value of this variable. Okay, sometimes I'm going to give you a polygon and I want you to solve for x. It might be an angle measure. There might be more than one x in here. Okay, but if I want to solve this, okay, I know the other angle measures. I need to know what the sum of those angle measures are. Now this is a quadrilateral, 4 sides. What do the angles in a quadrilateral add to? Well, if you don't remember the work, okay, or the answer, okay, our work would look like that. There's 360 degrees here, isn't there? Okay. I know those 4 angles have to add to 360. I can find x. X plus 71 plus 135 plus 112 equals 360. Okay. If I add those together, 71, 135, 135, 112. I'm at 318. So when I subtract, I get x is 42 degrees. Cool. Easy enough. Alright, now we get to switch a little bit here and talk about exterior angles. We've already talked about exterior angles with triangles. Hey, recall that you get the exterior angle by just taking the side length and extending it out. So here I have a what? 1, 2, 3, 4, 5. I've got a pentagon. Okay? And if I extend out each side, I've created 5 exterior angles. And I want to know, what do these 5 angles add to? We've got a rule for interior angles, n minus 2 times 180. Okay, but what would be our rule for the exterior angles? Okay. Well, I've got an idea. Let's go here. Okay, I'm going to start with a quadrilateral. I'm going to do the same thing. Okay. I'm going to extend each side once, and I'm going to look at the exterior angles. I'm going to shade this one in. I'll shade this one in a different color. Okay. Let's go green with this one. And it looks like I've got an orange left here. Okay. So what do these 4 exterior angles add to? Okay. Well, let me just pull these together here, and you're going to notice something happens. When I put the 4 angles together, what does that make? What's the sum of those angles? It's 360 degrees, isn't it? Okay. So what does that tell us? It tells us the sum of the exterior angles in a quadrilateral is 360 degrees. So does that mean the rule is the same as the interior angles? Is it n minus 2 times 180? Well, let's check it out by looking at a polygon with a different number of sides. Let's do a pentagon. 1, 2, 3, 4, 5. All right, let's color these in again. Green. What am I at? Red. And we'll just do this last one black. All right. All right. Sorry if that glitched there for a second. I get interrupted on my computer. So I've got the 5 colors shaded in for this pentagon on the exterior angles. I'm going to grab those angles here, put them together. I didn't do quite as pretty of a job on this one, but okay, we see the same thing happen here. Okay. The sum of the angles is 360 degrees. So it does not matter how many sides there is. Okay. It's really interesting. Okay. The sum of the exterior angles of a convex polygon is 360 degrees. Does not matter the number of sides. Pretty simple here. So if I want to find the value of x on this one, and it looks like this got cut off a little bit. I believe that is an x right here as well. Okay, sorry, that didn't show up very well in your notes. Okay, I have these 4 angles. They're all exterior angles. I know they have to add to 360. I've got a 2x plus x plus 85 and 89. They have to add to 360. That's 3x plus, that would be 174. Subtract my 174. Okay, 186. And divide by 3. X is 62 degrees. Cool. Last one. Good question here. Find the measure of each interior and each exterior angle in a regular decagon. All right, so we've already had the conversation about what's it mean to be a regular decagon. We've already, right here, the measure of each angle in a regular 15gon. So the number of sides is just different. Decagon tells us 10 sides. Can we find the measure of each interior and exterior angle? Well, interior angles, we've already been through this. We need to figure out what the sum of the interior angles are. We're going to take 10 minus 2 times 180. So that's 8 times 180, that's 1440. That's the sum of the interior angles. If we divide that by how many angles there are, that's 144 degrees. So the interior angle is 144 degrees. Now, how do we get the exterior? Well, do we know what the sum of the exterior angles are? Yeah, it's 360. It doesn't matter that there's 10 sides. So to find the exterior angles, we could take simply 360 divided by 10 is 36 degrees. So the exterior angles on the regular decagon are 36 degrees. Okay. Now, how do I know that I got this right? Look at this, 144. Look at that 36. I know for sure right now that I got this answer correct with both the interior and the exterior. Okay. Think about this. What's true about those two numbers, those two angle measures? They're supplementary, aren't they? Okay. What do exterior angles look like? Well, an exterior angle is what we get. Okay, I'll just draw part of a polygon here. The exterior, okay, sorry, I got interrupted again. Here's my interior angle. Okay, they're supplementary, aren't they? Okay, I know that these two angles have to add to 180. In fact, I know some students like to find the exterior first because it's less work, and then simply subtract from 180 to get the interior angle. So there we have it. We've got some great learning there that happened with the interior and exterior angles in polygons. Hey, remember that if it's a regular polygon, that all the angles are going to be the same, so you can do some simple division there. All right, thanks for tuning in. We'll see you later.